Unit 1, Lesson 3, Solving Absolute Value Equations. Objective: students will understand the definition of absolute value and use it to solve absolute value equations. So in order to talk about absolute value, the thing we're going to start with is what is absolute value. Absolute value is a way to make sure that whatever we get is a positive value, and we need it to be a positive value for some reason or another. The syntax works like this. Whatever you want to make be positive, you surround with vertical bars. If the value inside the vertical bars is a positive number, then you don't do anything. You can replace the vertical bars with parentheses. If the value inside the vertical bars is a negative number, then you multiply everything inside the vertical bars by -1, since you're distributing that -1. That'll make more sense on the next page. Some examples. The absolute value of 3, again, since what's inside the absolute value bars is positive, we do nothing. That's 3. The absolute value of -8, since what's inside the bars is negative, we multiply the -8 by -1, and we find the absolute value of -8 is 8. The absolute value of 4 minus 6, well, 4 minus 6 is -2, but since the value of that is negative, we multiply it by -1, and we find that the absolute value of 4 minus 6 is 2. You'll notice that whenever we have the absolute value bars by themselves, the answer is always a positive number. The absolute value of 2 plus 3 times -3. Well, 2 plus 5, and the absolute value of 5 is 5. 5 times -3 gives us -15. You'll see since the -3 is outside of the absolute value bars, it does not need to be positive. So we can get negative answers even if we have absolute value bars. Now this is a question to ask: what is the absolute value of x? Well, remember, we don't know if x is a positive number or a negative number. By the definition of a variable, x could be either one. So if x is positive, and we knew that x was positive, then the absolute value of x would be x. If x was not positive and we knew that, then we could say that the absolute value of x is negative x, because we would multiply it by -1, and -1 times x is -x. I want to stress the importance of that is we don't know if x is positive or negative by what's given in the problem. So we have to consider both possibilities. As a more concrete example, if the absolute value of x is 12, then we have to consider two possibilities. Either x is a positive number, in which case you could take away the absolute value bars and just say that x equals 12. The other possibility is that x is a negative number, which means that the negative x equals 12, and we multiply both sides by -1, which means that x equals -12. So since we don't know if x is positive or negative, then there are two potential solutions to this problem. Either x equals -12 or x equals +12. So in this case, these are both correct solutions to this problem. If you plug them into the beginning, the absolute value of -12 equals 12, and the absolute value of 12 equals 12, they'll both result in a true equation, which means that when we want to find the solutions to an absolute value problem, you need to find both solutions. To make this a little bit more complicated, we'll look at this example. 2y minus 4, the absolute value of 2y minus 4 equals 12. In the simple case, the case that 2y minus 4 is a positive number, we simply replace 2y minus 4, the absolute value bars around 2y minus 4 with parentheses. Since there's nothing to distribute, we can just eliminate the parentheses. So 2y minus 4 equals 12, so I would add 4 to both sides of the equation, getting me 2y equals 16. Then I would divide both sides by 2, getting me y equals 8. That is one potential solution to the problem, but it is not the complete solution because you need to consider the case that 2y minus 4 could be a negative number. So to deal with that, we say 2y minus 4 times -1, because remember, if the value inside the absolute value bars is negative, then you multiply it by -1. So in this case, I do have to distribute the -1. That gives me that -2y plus 4 equals 12. Because -1 times 2y is -2y, and -1 times -4 is +4. So in this case, I would subtract 4 from both sides. That would give me -2y equals 8. Then I would divide both sides by -2, which gives me y equals -4. You have to have both solutions to this problem in order to get full credit. The most complicated thing you're going to see is an absolute value bar on one side of the equation and with a variable in it, and on the other side of an equation, the variable outside of an absolute value bar. So let's see what happens when we have that. First, we consider the positive case, in which case we do nothing to the absolute value bars but change them to parentheses. That means 2t plus 4 equals 28 plus 6t. There's nothing to distribute with the parentheses, so we can eliminate them. So that gives us 2t plus 4 equals 28 plus 6t. We subtract 4 from both sides. That gives us 2t equals 24 plus 6t. Then we subtract 6t from both sides so that we can have t on one side of the equal sign and numbers on the other side. That'll give us -4t equals 24. We divide by -4. And that gives us t is equal to -6. That's one potential solution, but we have to consider both solutions. We also must consider that 2t plus 4 could be negative. So we take 2p plus 4, replace the absolute value bars with parentheses, and multiply it by -1, because when you multiply a negative number times -1, that'll give you the positive number, which is what we do when we have absolute value of a negative number. So now we distribute the -1. So that becomes -2t minus 4 equals 28 plus 6t. Now we add the 4 on both sides. That gives us -2t equals 32 plus 6t. We subtract the 6t on both sides. That gives us -8t equals 32. We divide by -8. 32 divided by -8 is -4. So our two solutions are t equals -4 and t equals -6. So just to reinforce that, we should check that work. So to check it, I plug in -4 into t, and I check that one. So I have 2 times -4 plus 4 equals, the absolute value of that equals 28 plus 6 times -4. So I do multiplication first. 2 times -4 is -8. 6 times -4 is -24. So -8 plus 4, the absolute value, equals 28 minus 24. -8 plus 4 is -4, and 28 minus 24 is 4. So in this case, I have the absolute value of -4 equals 4, and that is true. That works. So if -4 is the solution to this problem, and we've proved it by checking it. Now we move on to -6, which is the other solution we came up with. 2 times -6 is -12, and on the other side, 6 times -6 is -36. So we have absolute value of -12 plus 4 equals 28 minus 36. -12 plus 4 is -8, and 28 minus 36 is -8. So in this case, we come up with the absolute value of -8 equals -8. And that's not okay. That's not true. The absolute value of -8 is actually +8. So what we have here is something called an extraneous solution. Let's explain it. This is something that happens quite a lot. It's not a huge deal to deal with. You see this a lot where you'll get the absolute value of a negative number equals the negative of that number, like we just had. The absolute value of -8 equals -8. And this is called an extraneous solution. This is an extra solution that you generated in your algebra. It is not a correct solution. It does not solve the problem. So in this case, you would only have one solution to the problem, and that solution would be -4. So what it means for you is that you have to check all your answers for the absolute value equations and eliminate any extraneous solutions. If you give me extraneous solutions on a test, I'm going to mark that problem wrong. That's the end of what we have today, so here's the homework, and I will see you next class.